Paris, the fashion capital of the world. So what better place than to meet materials engineer Benoît Illy. He's sucking carbon dioxide out of the air and turning it into clothes that we can wear.
The problem with CO2 is that it's a very stable molecule. So in the first step, we activate it. So we turn CO2 into a very active molecule. And with this molecule, we can do with a very interesting chemistry. So we've got a two-step process to produce the building block of polyester. We are turning CO2 into new virgin fibers.
So, on to step one, activating CO2. We meet Dr. Ghosh, who's in charge of this all-important first step of turning gas into fabric.
So did you build this or design this yourself?
All these parts are designed in-house in fabrics. So we need three things: the catalyst, electricity, and the carbon dioxide. So here I'm getting contact of gas, solid, which is catalyst, liquid, and current.
So this is where Dr. Ghosh uses his engineering, because originally you're a chemist, right?
Yes.
So a chemist turned engineer. And why is he an engineer? Because you've actually designed and built the component that turns CO2 gas to carbon monoxide gas via a catalyst and a bit of electricity.
Exactly.
We can see all the parts here. What does it look like when it's all put together?
Yeah. So I need to put it together.
There's always nuts and bolts in engineering, whether it's chemical, mechanical.
Yeah, any
way.
This is the more or less complete cell.
Look at that. That is a sandwich that is going to convert carbon dioxide into carbon monoxide, stage one of the process.
So we'll implement now this cell into my catalytic bench.
So it's bubbling away, you're collecting carbon monoxide, and what happens next?
Next, this carbon monoxide, after collecting, will be used in the stage 2.
So I need to go over there now?
Yeah.
Okay, thank you so much.
Margot, nice to meet you.
Nice to meet you. So apparently you're stage 2?
Yes, I'm stage 2 and 3.
2 and 3?
Yeah.
Okay. And what happens in stage 2 and 3?
So basically I'm taking what Dr. Ghosh does. So it's making a gas molecule called carbon monoxide. And I will mix this molecule with a liquid. And this mixture liquid gas will obtain a molecule. And this molecule is the molecule for the stage 3.
Ah, okay. So you're basically mixing one chemical with another, and then that chemical with another chemical to get the liquid that you need, which is the major ingredient of polyester.
Yeah, exactly.
So Benoît, we've been seeing the magical process that happens in your lab going from CO2 gas to liquid that is a key ingredient for making polyester. Tell me about polyester. Is it a good or bad fabric?
Polyester is huge. We don't realize it, but 60% of the cloth we buy today are made from polyester. And today, so polyester is a plastic made out of petroleum. And with our solution, we are replacing the petroleum product with CO2.
So in the lab, we got to a stage where Margot was creating a key ingredient in liquid form, which apparently then goes to Germany. So what happens in Germany?
So we take this liquid and we mix it with a solid to produce polyester. So polyester is a polymer. That means that it's a repetition of building bricks. A, B, A, B, A, B. So we produce today the brick A and we mix it with a brick B that is used in the industry today to produce polyester pellets. So it's a small chunk of plastic that are used to produce textile.
I cannot believe at this stage, seeing it in solid form, that this becomes a fabric. So what do you do to this next?
So you take that, you melt it, and once it's melted, it's easy to thread it, and you can produce a polyester thread like this. A very long fiber, so this fiber are the repetition of the AB, AB, AB molecule we talked about. The last step is to knit it to get a fabric, and when you knit it, you will get this nice fabric that is exactly the same as what you wear today.
I think this is the moment we've arrived at the result. Wow, so from a gas to this.
So our main goal is to decrease the carbon footprint of the textile industry. It's huge, and with the technology today, we can reduce the carbon footprint by 70%, but this is only the first generation of our product. We are working on a second product that will be carbon negative, and it will help to solve climate change.
And the idea that this is not only sustainable, but could be reversing the negative effects of climate change is truly miraculous. Thank you so much.
Thank you.
So I'm looking at the label of my jacket and it says 100% polyester. What are the chances, after being with Benoît Illy and his team, seeing how polyester is made in a sustainable way? This jacket is probably not sustainable, in fact I'm pretty sure it's not, but the idea that we can suck carbon dioxide out of the air, turn it into something we can wear, just blows my mind, and I've seen it with my own eyes that it's possible, and that is where engineers like Benoît really make a difference.